So lastly, let's look at what we know about which brain areas are involved in colour perception. So we could ask, is there a specialised colour centre in the brain that is responsible for colour perception? Well, if we look at neuropsychology, there's some evidence that this is the case. We know that patients with cerebral achromatopsia perceive the world to be shades of grey. There's nothing wrong with their retina. They still have the rods and cones intact. There's nothing wrong with the pathway all the way to the cortex, but there's some problem at the cortex, so they can't perceive colour. So just a reminder, we have the trichromatic stage at the level of the retinas and the photoreceptors. We've been through this before. And then we have a colour opponency at the level of ganglion cells and the lateral geniculate nucleus. Okay, so trichromatic stage at the retina, then this information is being combined and projected to the lateral geniculate nucleus. And then that in turn is projected to areas V1 and V4 of the visual cortex. The LGN here is in the centre. And in the primary visual cortex, these two areas, V1 and V4, seem to be primarily involved in colour. But it's quite interesting in the way in which these two areas differ in their operation. In area V1, we have small patches of cells called blobs that respond or get excited about the colour of the stimulus, the actual physical wavelengths, okay, or the actual activation of the rods and cones. But we also, interestingly, have this area in V4 where we have cells that respond to the perceived colour, okay? So if I flip back to my example before, here, so area V4 would be interested in the perceived colour here of brown and orange, but area V1 would be interested in the actual wavelengths coming off that particular part of the object. So they're going to respond in very different ways. Okay, so here we have single cell recording in areas of V1 and V4. So we're just looking at one particular cell. So in V1, remember, the cells are tuned to the actual wavelength being emitted by the object. Okay, so this particular V1 cell, it's tuned to green. So when it's viewing this white object here, it's just going to be firing at its background rate. But when it's viewing a green area, it's going to fire at a rapid rate. This is the wavelength that it's tuned to. So this is when we're viewing this pattern under white illumination. But now look what happens when we view it under green illumination. Remember, this cell is just interested in the wavelength of light coming off the object. And you can see that it's going to get almost as excited by this white patch, which is now a pale green, than it is by this dark green area. Okay, so now let's look at recording from a V4 cell. And again, this V4 cell is tuned to green, but it's interested in the perceived colour, not the actual wavelengths coming off the page. Or off the object. So again, just like we saw before, under white illumination, V4 isn't going to fire very much for the white background. It's just going to fire its background rate because it's tuned to the perceived colour of green. Then when it's actually shown green, it's going to fire at a rapid rate. Okay, so under the white illumination, V1 and V4 are going to behave in exactly the same way. One's tuned to the green. One's tuned to V4 tuned to the perceived colour. V1 is tuned to the actual wavelengths coming off the page. But in this white illumination, the two things are identical. It's only when we change the illumination that we see a difference. Okay, so here, V4 cell, again, it's tuned to the perceived colour of green. So even though this area is now emitting green under this background, V4 is tuned to the perceived colour. Okay, so the perceived colour under here is still going to be white. Okay, just remember when I showed you these patterns and I changed the illumination, you perceive the colour as remaining more or less constant. And for this area here, which is actually green, it's perceived as green, it was green up here, it's green down here, the V4 cell again is going to fire. So it's quite interesting. We have these areas that are interested in the wavelength, and those that are interested in the perceived colour. If you wanted to be very bold, you could say that V4 represents the kind of conscious perception of colour. Although things get very tricky when we start talking about the brain like that. But certainly we know that there are cells in V1 and V4 that are tuned both to the wavelength and to the perceived colour. Other cortical processes that we know about to do with colour vision. There was a study, I'm not going to attempt to pronounce this researcher's name, but this researcher investigated areas of the brain that were more activated by colour stimulus than by black and white stimulus. He found that areas V1, as we've just seen before, were activated, but also areas of V2 and V3, but also area V8 was activated. And he investigated areas of the brain activated by the colour after effect. Remember, I showed you those examples in the first year perception lectures, in the colour lecture. So if I get you to stare at a yellow object, for instance, and then take it away and show you a white background, you'll have the after effect of seeing a blue object. And what he found was that the only area that was interested or was activated by the after effect was area V8, not the other areas that are only interested in when you're actually viewing an object. So again, you have to be careful of these statements, but it suggests that area V8 might be the site of colour consciousness. But what we mean by areas involved in consciousness is a very slippery slope. But we do have some handles on the brain areas that are interested in colour, and I'm only touching the tip of the research that's out there. Okay, so a summary of colour constancy. Just to summarise, colour constancy is the perception of constant colour despite changes in illumination. It's a more complex problem than light constancy. It seems to be done by an appreciation of the surroundings or what the ambient lighting condition is, and your memory of what colour different objects are, if they're familiar objects. And the visual areas of V4 and V8 are thought to be the sites of colour perception, or the sites of perceived colour. Key terms again, so these are good things to bear in mind for multiple choice examinations. Colour constancy, light constancy. Again, these key terms of reflectance, illumination and luminance. Retinex theory, the anchoring heuristic, reflectance and illumination edges, fuzziness, planarity and ratio magnitude heuristics, colour memory, and these visual areas of V4 and V8. And again, I would recommend for all of this lecture that you go back and read the relevant chapter in the Goldstein book that we used last year for sensation and perception, and go through your sensation and perception notes from last year. Okay, thank you for listening. As I said at the beginning, that this is quite a tricky topic, so don't worry if you don't get all of these technical terms into your head straight away. Okay, that's it for today. Thank you for listening, and I'll see you on the next one.